Hey guys, how are you doing? I hope you're doing well. This is JSer who is not good at algorithms. In this video, I'm going to take a look at number 938 of LeetCode, range sum of BST. BST. We're given a root node of binary tree, search tree, binary BST, return the sum of values of all nodes with a value between L and R, inclusive. Well, it seems very, if we do it straightforward, like we could just loop through all the nodes and pick up the and sum of them up, right? So it's actually linear time, but the title already tells us that this is a BST, so linear time would not satisfy the engine, right? We need to do better. Well, let's actually, because it's a BST, if we want to search a range, we could do something like a binary search, right? And to narrow down ideally, for each check, we could remove half of the numbers. Like for the brute force, we loop through the numbers one by one, but now we could like skip a lot of the numbers, which make the algorithm much faster. Now let's analyze the basic form of this problem, like 10, 5, 15. So for the range of numbers, because we're given an interval like L and R, the numbers fall into this range. For the relationship between this range and this root node, what's the relationship? Well, of course, there are two possibilities that the 10 is in the range, right? If it is in the range, then the problem becomes the left, the L to this number, and 10 to the right R, right? So it becomes two subproblems which will again recursively falls to this node, right? So and then if it is not in it, then if it is smaller than it, smaller than R, if smaller than R, or smaller than L, then we could just go to 15, right? If it is bigger than R, then we need to go to 5. Well, since it's a typical recursion problem, and we need to get the sum of each subtree, and then sum them up and return, right? Return. Cool. Okay, let's do it. So create a walk method. The walk method will get a node. This walk method we return the sum to a range with left and right, because if the node is in the range, we need to change the interval from R to L, the root node, right? Okay, is there any irregular case if root is null? Return 0. Okay. So now let's do the check. So const val equals node val, right? If val is smaller than L, which means it is not in a range. It is not in the range. Or if it equals to L, if it is equals to L, val will need to be sum, right? So if it equals to L or equal to L, yeah. If it is smaller or equal to L, then the interval actually falls to the right. And then we get to const a sum equals walk node right. Left, still it's L. No, left, right. I use min max. Min. So this is min and max. So I will return sum plus equals, if val equals to min, then plus val, right? If not, 0. Cool. If val is bigger than max, then const sum equals walk node left min max. Return sum plus val equals to max, val 0. Okay, for the other case, sum left equals walk node left. The minimum does not change, but the max changes, right? If the val is, so yeah, max changes. Max not change? Wait a minute. So the minimum val max. Actually, if it's in the middle, then max doesn't change because it doesn't matter. Const sum right equals walk node right min max. Return yeah, okay, there's not I made a mistake. There's nothing called relationship between this node is in a range or not. Actually, it's subtree and the right subtree, right? This node, shit, I'm sorry, I made a mistake. So const sum left. But the BST will help us, right? Yeah. As some let sum left equals 0. Let sum right is equals to 0. We will walk to the left unless what? Unless if node val is bigger, if it is smaller or equal to, yeah, if it's bigger than the minimum, if it is bigger than the minimum, I will go to left, right? Yeah, walk node left. If node val is smaller than max, if node val is bigger than max or equal to max, we don't need to go to the right. Yeah, sum right equals walk node right. And so we return sum left plus sum right plus let sum. If node val is bigger than min and node val smaller than max, sum plus node val. And finally, return sum. So I will return walk root LR. This should work, right? Like for trees, like let's review one more time before we submit. I'd like to try block free. 3, 7, 18. So now we're going to get 7 interval from 7 to 15. Cool. Now the node val is 10. 10 is bigger than 7, so we'll go to 5, right? And the 5, yeah, we found the problem. The min max is not passed down. So node val 5 is bigger than 7? No. And 5 is smaller than, no, wait a minute. Yeah. If it is smaller than max, max is 15, yeah, so we go to right? So we walk to 7. And 7 is bigger than minimum? No. 7 is smaller than max? Yeah. And then we go to the right, which is null. Yeah. So if node is null, return 0. And now for 7, yeah, sum is 0. If 7 is bigger than 7, yeah, so we return 7. And now for 5 is not matching, so 5 returns 7. And 10 will get left and get right, go to 15. Node val 15 is bigger than it, so we'll go to left, 0, 15. And 10 itself, yeah, I think it should work. Pending, judging. Cool. I tried to submit. Seems like a lot of people are using LeetCode now because pending. Yeah, we are accepted. Let's analyze the time and space complexity. Time. You see, for each time we only walk to one tree, right? So actually it depends on the left and the right. If it is like there should be all the nodes. Time actually depends on how many nodes are to be collected, right? Well, obviously this is better than n. N is fixed, right? It depends on L and R. Space. Actually, there will be a call stack. It's node tree height. Well, averagely it should be log n. Cool. Actually, we finally did it with one try. Hope it helps. For trees, always think about the recursion. Yeah. And get the recursion relationship. At first, I made a mistake, and I corrected when I'm writing this if clause of the child node. Let's pay more attention to that in the future. Okay, that's all for this one. Hope it helps. See you next time. Bye bye.